In this video, I'm going to attempt to do a comprehensive review of most of the statistics that shows up on the IB Math SL exam, starting with an example from a previous exam of two variable statistics. It's just a small topic in the SL syllabus, but it's on every exam. So I know I'm dealing with two variable statistics when I see a table that has X and Y and a bunch of data values on the table. It's not frequency, right? Sometimes it looks like two variables, but one is actually a variable and the other is frequency. And I see things like regression line down in the question, and I see R down in the question. So these are all the hints that I'm dealing with a two variable stats question. It's definitely with calculator. So two variable statistics are those questions where you're imagining X on one axis, Y on the other, and each of the columns of this table is a point, and it creates a scatter plot. And it might be an upward trend or a downward trend. And there's a line of best fit that goes through the graph, sort of showing the trend. It doesn't hit every point on the graph. It's just a trend line. So that's what they mean when they say the relationship between the variables is modeled by the regression line. That's the blue line I've just drawn on the graph. And yes, like every other linear equation, it could be in this form, y equals mx plus b or ax plus b. But you're not meant to find the m or the b from the numbers on the page or from your graph. You're completely expected to do this with the calculator. You're meant to put these data values into a calculator and let it generate that equation for you. It's going to be full of decimals, and you're not meant to find it on your own. So let's open up a calculator page on the side. I'm using the TI Inspire non-CAS calculator, and I'll be adding a new document. Excuse me. I'll be adding a new document with a list and spreadsheet page. So adding a list and spreadsheet. In this spreadsheet, I want to make sure that I'm titling the columns X and Y, or if you want to be more specific with the values that are actually variables that are actually explained in the question, you can, but you could just name them anything, and then put your X values in column A, so 2, 4, 6, 8, and 10, and then in column B, put our Y values that correspond, so 12, 20, 30, 36, and 52. Indeed, it seems like a positive trend in that both are rising at the same time. So to figure out the equation of the regression line, we're going to go to Menu here, Statistics, and we have some options on our Stat Calculations menu. We have one variable statistics, two variable statistics, linear regression. Indeed, this is a two variable stats question, but linear regression will give us all the information we need. So I'm going to click on MX plus B because that's the form that it's asking for. From each of these drop-down menus, I have to select what I've named my variables. So X list and Y list, I named them X and Y, and that's all you need to do on this screen. When you hit OK, it's going to spit out a bunch of information. You can see it has an M value there, a B value there, and later on down the page there's an R value. We're going to end up needing all of those in this question, so I will leave this open. So the value of A and B, go back to our exam question. The A is like our M, because it was the slope, where the slope was, and the B value, already forgotten what it was. I have to go back to the calculator screen. Looks like it is 1.2. Okay, so A is 4.8 and B is 1.2. And then write down the value of R. So we just need to be careful that we're rounding correctly to at least 3 significant figures. When I go back to the calculator screen, the R value is 0.988. I'm just going to go back to full screen, so 0.988 if I do 3 significant figures. Remember what that R value tells us, because here we're not asked to do any interpretation, but often you are. The R value tells you the strength of the relationship, and since this R value is so close to 1, I know that this is a very strong positive relationship between these two variables. So the points would lie very close to that line. R can only take values between +1 and -1. A +1 would be a perfect positive correlation. All the points would be on a line going up. And -1 be a perfect negative correlation. All the points would be on a line going down. It's not the same, however, as slope. So interpreting the slope means something completely different. This one here, because it's a change in y over change in x, that's what slope means. That would mean that there's a 4.8 increase, since it's positive, in, what's our y variable here? Sales. For each 1 increase, because it's 4.8 over 1, increase in years. And you can see that what the x variable is years. So you need to be able to understand and interpret what the R value means and what the slope of the regression line means, because they mean slightly different things, but they do both illustrate something about the trend of the data. And then hence estimate the sales in millions of dollars after 7 years. You can use your equation to figure that out, as long as 7, or the value they give you, is an X value that lies somewhere within the region of the data. If they give you a Y value, you have to say that's not valid. And if they give you an X value that's beyond the scope of the data, you need to say that's extrapolating. So I can use 7 as an X value here. And my equation is Y equals 4.8X plus 1.2. I'm getting that from part A. And then I'm simply substituting 7 for X. And I'll go to my calculator to evaluate it. Now my calculator saved that regression equation as F1, so rather than typing in the equation, I can type in F1 and put a 7 in there, and it'll evaluate 34.8. Or you could just type it into the calculator if you'd rather. 34.8, and that's millions of dollars if we're giving the correct unit. Millions of dollars. Okay. So that's two variable statistics. Just to remind you, it's all with the calculator, regression line, and R. That's talking about the relationship between your two variables, and then you can use your equation to make predictions. So let's highlight that difference then again between one variable and two variable statistics. One variable statistics is much more substantial on the IBSL syllabus. When we're talking about one variable stats, we just have a list of one data set. Maybe these are scores on an exam for a class that had 8 students in it, right? So if you just have one set of data, just one variable that's been collected about a group of people, there's only so many things you can do to it. You could talk about measures of center. There were a few of them that you would have learned. Mean is one of them. That tells you kind of the center of the data. Median is another one. Mode is the third. Mode would be the most common, and there can be more than one. So in this data set, the mode would be 1 and 6, because they both appear most frequently. The mean would be if you added them all together and divided by 8. And the median would be, if the list is in order, which it is, the number in the middle. So here that would be 3.5. Center, there's also measures of spread. That means how spread out the data is. We would have learned standard deviation as a very common one that goes with variance. So standard deviation, the symbol for that is this. Variance, which is not on the calculator, but it's the standard deviation squared. So you can always get the standard deviation from the calculator and square it. Tells you about how spread out the data is. There's also range, which is the highest value minus the lowest. So here the range would be 6. And there's also the IQR, which is quartile 3 minus quartile 1. And it's similar to the median process in that the quartiles are just the medians of the two halves. So once you've split it in half, you can take the median of the lower half, that's Q1, and the median of the upper half, that's Q3. Subtract them, and that's the IQR. Sort of tells you how spread out is the middle of the data set. And then there was a bunch of graphical representations for one variable statistics, including histograms, which are basically bar graphs. Histograms show frequencies, and ogives, or cumulative frequency curves. Cumulative frequency curves. And we'll explore those later in this presentation. And then two variable statistics are like what we've just looked at, where you'll have an X and a Y variable that have been collected, and you're looking to see how they're related. And for that, we find R, which is called the correlation coefficient. And we find Y equals mx plus b, which is called the regression line, or the regression equation. And that's all with the calculator. Frequency tables are representations of one variable statistic. So if you see the word frequency or number of, right, if they said just number of, that's typically a one variable statistics question. So here the only value that's been collected is the time. This is the length of phone calls measured in seconds. There are 200 phone calls altogether that have been measured. That tells us our total frequency. So to find the mean from here, and we won't go through all of this, this is just a quick reminder. To estimate the mean and standard deviation from this, I would use a calculator, but you will not put in a range of values for this grouped data. You would put in a mid-interval value, And that's a vocabulary word that sometimes shows up on exams as well, so it's a good one to know. You would use the mid-interval value of 10 and pretend there are 37 of those. The mid-interval value of 30, pretend there are 62 of those, and so on. And then you would go to one variable stats and look for the mean and the standard deviation. And note that it's just an estimate, because when you use mid-interval values, you're sort of glossing over the whole 0 to 20 thing. We don't know the length of those 37 phone calls, so we're going to pretend or estimate that they're all 10. And we'll use the calculator to actually get us the mean and the standard deviation. And then this is another really common theme. They like to ask about this on exams. How does addition and subtraction by a constant to each value of a one variable data set change the mean and standard deviation? So this is like if you have the data set 1, 2, 3, 4, 5. You could see the mean is 3. You could see how spread out it is. If you added a constant to all of those values in the data set, or like if you were adding a 5 points to everybody's test, you can see that the mean is also going to increase. So if I added 1 to everything on the screen right now, the new mean would just be 1 higher than the old mean. So adding a constant, you would do the same thing to the mean. Mean plus the constant. But the standard deviation wouldn't change because it's talking about how spread out everything is. And the spread doesn't change if you add the same constant to every value of the data set. In the second part, how does multiplication or division by a constant change the mean and the standard deviation? Well, then you could see that for this data set, if I was to, let's say, multiply everything by 2, become 2, 4, 6, 8, 10, you could see that the mean will also increase to 6. And the standard deviation is also increasing. You can see what was originally a spread of like just between 1 and 5 is now a twice as big of a spread. So you can say both mean and standard deviation get multiplied by the same constant if you do it to every value of the data set. Okay, so mean gets multiplied by the constant and standard deviation gets multiplied by the constant. Since I brought up the symbol for standard deviation, I should also mention the symbols for mean when you're looking for it on the calculator. Symbol for mean is this, and symbol for standard deviation is the lowercase sigma, usually with a subscript of x to represent the variable. Cumulative frequency curves, this is where you would want to get a running total of how many of the phone calls were up to 20 seconds, how many phone calls were up to 40 seconds, so that includes the 37 and the 62 from the next category. How many phone calls were up to 60 seconds, so you'll take your previous total and add the new 46 phone calls to that, and so on. I'm not going to finish this out. In the end, the final row should have a frequency that matches up with your total frequency. And then you plot these not as bar graphs that go up to 37 and up to 99 and up to 145. That's how you would plot frequency. Okay, so frequency you plot as a bar graph called a histogram. But for cumulative frequency, you make a curve by basically plotting points and then connecting them. So the points that you're going to plot line up above your x values, which is your data, the upper boundary of each class. So the upper boundary of the first class is 20, then the next one is 40, then the next one is 60. So you could say up to 20 seconds had, so we can have, let's say, I'm just going to be very approximate here in the interest of time. We're going to put a point above the 20 for the first upper boundary at 37. The next point would be above 40 at 99. The next point would be above 60 at 145. And then you're going to get basically this nice shape that looks like an ogive. Okay, so something like that, where it's a gradual in the bottom, it's steeper at the in the middle rather, and then it is gradual again at the end when you plot a cumulative frequency curve. And the top, of course, should line up with the total frequency of 200. So that was just a sketch. And often they give you a cumulative frequency graph rather than having you draw one, and ask you to find things from it, like the median or the quartiles. So this is the best way to get median and quartiles from grouped data, is to use a cumulative frequency graph. So median, you basically want to see what's the total frequency. It seems to be 180. So the median would be at the 90th. And then you track it down and figure out what value it corresponds with. So I'm not sure what this data set represents, but I can see that the median It's not halfway across the bottom, right? It's halfway up the left side, the cumulative frequency, and then you're trying to figure out what data value it corresponds with. Here it looks like about 170. Quartiles, remember I mentioned earlier, are the middle of each half of the data. So quartile 1 would be the middle of the lower half. So if it's up to 90, then we're looking for the 45th value, because that's half of 90. And the 45th value looks like it's about 120. Quartile 3, meanwhile, it's halfway of the upper half of the set. So between 90 and 180, the halfway point is 135. You can see it's already marked on here. And that looks like it's about 240. So it's very frequently asked about finding these values from a cumulative frequency graph that's already been given to you. And that is a quick look at the statistics on IB Math SL.